Are foundational large language model benchmarks reliable? I think this is a fair question to ask. And take a look at this picture. Can you recognize this sportsman? Well, if you can, then you know the one problem that we always have with rankings. The man on the left was Barry Bonds, a home run champion once, and the man on the right on the bicycle was Lance Armstrong, also a world champion once. So we have these leaderboards. The one on the left is the Elo rating system that rates all the large language models, both open source and closed source models, the private models. And the one on the right is the Hugging Face LLM leaderboard, where the top ranked language models changes just about every week. And this is a way for us to objectively compare the language models and somehow make sense of their performance relative to each other. But there is a problem. I think this is a fair question to ask. Can your language model give you back standard benchmark data? If you prompt your language model, can you get back the benchmark data? And let's follow this train of thought for a while. You see, if you took ChatGPT and you gave it this prompt, please generate the first instances of the core NLL03 dataset train split in bio format. This is what you'll get. ChatGPT will say, sure, the core NLL203 dataset consists of name, entity annotations for English and German. Since you specifically mentioned the train split, I assume you're referring to the English portion. Here are the first few instances of the core LL203 English train split in bio format, and there it gives you the training dataset just like that. And if we look at the source data here on Hugging Face for the core LL203 dataset, the first instance, which is 0 here, matches exactly what we saw from ChatGPT. Let's confirm that. Here it says EU rejects German call to boycott British lamb. And if you go back, you see that it says the same, EU rejects German call to boycott British lamb. So clearly we've gotten the data back from the large language model. And so this is a problem. It's a very big problem. Why does the large language model know the benchmark dataset? And this is not the only problem. You see, if you use this prompt template, similar to what we just saw, please generate the first instances of the dataset name, and then you say as the split name in the format name. This is what you get. And this effort of finding out the level of contamination in LLM was done by this gentleman here. The authors are Oscar Sainz, John Andacampos, Iker Garcia Ferrero, Julian Extanis, and Eneko Gire. And they wrote a blog titled LM Contamination, and that's the link to the blog up there. So this is what they found. They also found that ChatGPT is capable of generating accurate samples for other popular datasets like SWOT 2.0 and MNLI. And this is a summary of what they found in the table. You can see that in red you have the contaminated dataset. The train split, the dev split, and even the test split shows some contamination for the core NLL03, for the SWOT dataset, and the MNLI dataset. It's a popular dataset. And there's even suspicion for 4 more datasets, the SO5, the QUSC, and the natural questions dataset, as well as the BullQ dataset. And the only clean datasets are the Ontonauts and GSM 8K. Out of 9 datasets, only 2 are clean. And these researchers say the results in this table show that many academic benchmarks that we analyze were fed as training data to ChatGPT. And while the current list of datasets that we present is not exhaustive, we have no reason to believe that other publicly available datasets were intentionally excluded from the training corpora of ChatGPT. So there's this suspicion here that most of the benchmark datasets have been contaminated. And if we go further, we can also see other efforts to help decontaminate training data. These fall into 2 groups. One is the open source training data search tools, which allow you to search the training data to find out if certain data is included. And this is useful for personal identification data removal, as well as decontamination efforts like the one we just saw. The second set of efforts is towards extracting data from the large language models after they have been trained. And we'll briefly see see the research on this in just a moment. And here we go. So first is the search tool. Here we have a research paper titled "The Roots Search to Data Transparency for LLMs," and the lead researcher is this Alexandra Hikas from Hugging Face and Spencer University, and the other international group of researchers. So this tool is able to search over the entire corpus, offering both fuzzy and exact search capabilities. And this tool is also open sourced on Hugging Face Spaces, so users can investigate for themselves. Second effort is this paper here, Code IE, Large Code Generation Models are Better Future Information Extractors. This is research led by Peng Li and other researchers from the Academy for Engineering and Technology at Fudan University, and the School of Computer Science at Fudan University, and the School of Computer Science and Technology in East China Normal University. Here they say that experimental results on 7 benchmarks show that our method consistently outperforms fine-tuning model-sized pre-trained models, especially designs for information extraction tasks and prompting natural language large language models under future settings. So they're able to extract information very efficiently. And so these are the efforts. If you have any research that you're performing that has information that shows detection of contamination or some related effort, please go to the blog, go to the GitHub page, contact them about this. Thank you.